Okay, so at the end of the last video, we were on question number 4. We had finished A. We were just starting B. We had found the threshold wavelength of the metal, which was cesium, and part B then asked us for the kinetic energy in electron volts of the photoelectrons that were going to be released when light of wavelength 425 nanometers struck the metal. So the first step is to find your F. So we know C equals F lambda, so F is going to equal C over lambda. So 2.9979 times 10 to the 8th meters per second over this 425 times 10 to the negative 9 meters will give us a frequency of the light coming in to be 7.05388 times 10 to the 14th hertz. And usually your frequencies are 10 to the 14th, 10 to the 15th. So now we can go over here and find our EK max. So it's equal to H, which is 6.626 times 10 to the negative 34 joules seconds, times the F we just found, which was 7.05388 times 10 to the 14th hertz, and then minus our WO, which we were given back originally in the question, which was, I guess I can put it in here, 1.96 electron volts. Again, one's going to end up being in joules, the other in electron volts. You can't just subtract them, you need to switch one. So when we multiply this guy out, it ends up being 4.6739 times 10 to the negative 19 joules, and then that'll be minus 1. What did I just say it was? 96 electron volts. But the question wants the kinetic energy in electron volts. So you can divide this by 1.602 to the negative 19 joules per electron volt. And then subtract your 1.96. And when you do, you get 0.9575 electron volts. Final answer, number 4. Okay, I also asked you to do the questions numbers 2 to 6, I think it was. Yeah, on page 570. So page 570, number 2. Under problems. So stopping potential of a certain metal is 5 volts. VO, 5 volts. What is the maximum kinetic energy of the photoelectrons in electron volts and then in joules? So VO is equal to EK max over Q. So EK max is equal to Q times VO. So in electron volts, it's 1 electron volt times 5 volts. EK max is equal to 5 electron volts, part A. In joules, it's 1.602 times 10 to the negative 19 coulombs times 5 volts. So EK max will be equal to, what is that, 8.01 times 10 to the negative 19, and a coulomb times a volt is a joule. That's number 2. Number 3 says, to block the current in a photocell, the stopping potential is 3.8 electron volts. So VO is 3.8 electron volts. Find the kinetic energy of the photoelectrons in joules. So again, VO is equal to EK max over Q. So EK max is equal to Q times VO. We want it in joules, so you need to use 1.602 times 10 to the negative 19 coulombs times 3.8, there's a point in there, I swear, volts. And you get an EK max to be 6.0876. times 10 to the negative 19 joules. Number 4. What potential difference, in other words, you're looking for VO, what potential difference is needed to stop electrons having a maximum kinetic energy? So this time they're giving you the EK max. It's 4.8 times 10 to the negative 19 joules. So VO is equal to EK max over Q. So 4.8 times 10 to the negative 19 joules over 1.602 to the negative 19 coulombs. You should end up getting a VO of 2.996 volts. Number 4. Number 5 says the threshold frequency of sodium, FO, is 4.4 times 10 to the 14th hertz. What, I lost the question. How much work must be done to free an electron? In other words, what is the work function? Because that's why it's called the work function. Because it's the work that needs to be done on the material to free the electron. It's equal to HFO. So 6.626 times 10 to the negative 34 joule seconds times 4.4 times 10 to the 14th hertz. Multiply them together and you should get 2.91544 times 10 to the negative 19 joules. And the last one, number 6. If light with a frequency of 1 times 10 to the 15 hertz falls on the sodium in the previous problem, what is the maximum kinetic energy? So you're looking for EK max. So we use our equation. EK max is equal to HF minus WO. So EK max is equal to H is 6.626 to the negative 34 joules. F is the 1 times 10 to the 15th they just gave us. And W is O is what we just found, 2.91544 to the negative 19 joules. Okay, do the math, and you should get 3.71056, I think, times 10 to the negative 19 joules. And it doesn't say in joules or in electron volts, so you can just leave it in joules if it doesn't ask you. And there they are. There are all your questions done. Okay? Time to practice a few more, I think.